Okay, we're going to look at postulates or axioms. And these are statements that we're going to just accept as true because we cannot prove these. Okay, we can't actually prove these things. We just have to believe and understand that they are true in geometry. Some of these we have dealt with before. We just haven't dealt with them in terms of an actual postulate. So you can read them all. They're in your book. 2.1, just to get us started, says through any 2 points there's exactly one line. We've talked about that before. That's the best that we could do really for the definition of a line. It contains 2 points. 2.2, we remember this too. Through any 3 non-collinear points there's exactly one plane. And a lot of these should seem pretty familiar to us. So I won't go through all of them with you. Again, they're in your book. You guys can be able to read them if you would like to. They will be useful for example 1 though. And really all I want you to do is identify which postulate or axiom they're talking about in each one of these. So letter A, line M contains points F and G. Point E can also be on line N. Okay, if we would go back to that previous slide with all of those axioms or postulates on them, you would see that that is fulfilled by 2.3. I'll go back so you can see it. 2.3. A line contains at least 2 points, which means I could have more than 2 points on it if I would like, which is happening in this one, letter A. Okay, I have actually 3 points on that line, which is possible. So just identify which postulate we're talking about. It's 2.3. Letter B, lines S and T, they intersect at point D. That would be postulate 2.6. Again, I'll go back to the previous slide so you can see it. 2.6 is down here at the bottom. When 2 lines intersect, they intersect at exactly 1 point. You can see that from the diagram as well. S and T, they intersect at point P. 1A, points A, B, and C determine a plane. If we go over to the picture, here's point A, here's B, and here's C. All 3 of those points are non-collinear. And since all 3 of those points are non-collinear, they do form a plane. That is postulate 2.2 that they're talking about. And then finally, planes P and Q, they intersect at line M. That is 2.7. Again, I won't flip back. You guys can be able to read those on the previous slide. Example 2, now is where it gets a little bit more interesting. You're going to have to determine whether these are always, sometimes, or never true. And please explain your reasoning when you're doing this. So if I have 2 coplanar lines, in other words, I have 2 lines that are on the same plane, and they are intersecting, then the point of intersection lies in the same plane as the 2 lines. That is always going to be true. That is always going to be true. Anytime any points that lie in the line, then those are also going to lie in the same plane as well. So that is an always statement. Letter B, 4 points are non-collinear, meaning that 4 points are not on the same line. Well, you could actually give me an actual example of that where 4 points do lie in the same line. But they don't always have to be, so this would be sometimes. If it's easiest to explain using a picture, you certainly may. Here's an example of where they do lie in the same line, and here's a picture where they don't all lie in the same line. A, B, C, D. Therefore, it's sometimes. Not always going to be true, but it's not never. 2A, 2 intersecting lines determine a plane. This one's interesting. We should draw this one out to help ourselves explain it. When we talk about lines, okay, we need 2 points to determine a line. So I'm going to draw out 2 lines, and they're intersecting. So I'm going to draw 2 intersecting lines. There are my lines. I'm going to put 2 points on each line. I'll put a point there. I'll name the intersection point, and then I'll put a point here. So I've got A, B, and C. B is technically on both lines. So So now if I look, to determine a plane, I need 3 non-collinear points, which I actually have satisfied right there. A, B, and C are on completely different points, or are not on the same line. So 2A is actually always going to be true. 2B, 3 lines intersect in 2 points. So you can try this as much as you would like to get lines intersecting in 2 points. But the only way that this is going to work is if 2 of the lines are exactly the same. So 2B is going to be never. And that's what I would say for my reasoning. 2 lines have to be exactly the same. It's never going to work in our case.